And let me talk about a little bit about the commit thing. Because when you commit, you will see something like that as a result or as a response from Git. And this looks a little bit strange because, I mean, for sure 1.5 change, 1 insertions, 0 deletions, that's clear. Adding a new entry is obviously the commit message. But then there's this strange number, which is 2BACA5A. And what's that? That's the important part, and that's where this design goal security comes in. Because this is the revision number. I mean, this looks like a little bit strange for a revision number because you're used to revision numbers like 1, 2, 3, 4, 5, etc. But in Git, you don't have incremental revision numbers anymore. A revision number looks like this. So that's a full revision number in Git. Looks a bit strange. The first 7 characters are displayed during the commit. So what's that? Strange. But if you're a little bit familiar with hash functions, you will notice that this is a SHA-1 hash function result. And why is it that way? It's easy. Because Git makes sure that Git stores checksums. So this is basically your revision number. It's nothing else than just a checksum that includes a checksum over the commit message. It includes the checksum includes the diff that is committed. The checksum includes your username. The checksum includes the revision number of the revision before your commit, so the parent revision, etc., etc. So this checksum is really unique to your change that you created in exactly that moment. And by using a hash function like a SHA-1, it is nearly impossible to find a commit that has exactly the same hash but has different content. So this hash number is usually really unique in the world, and this is the whole safety feature of Git, because it enables you to always check if your files, if the diff in the file, the content of the file, if you can check them by just verifying them against the checksum. You just run the checksum over your files and check if at the end you will have the commit checksum. If that's the same, and if it's not, you have a local repository, which is not possible. It's a burden, but in Git it is. And because it also includes the parent revision number, it's really, if you just verify one revision number, you have a chain of revisions that are changed, that are checked. So this is the whole notion of security in Git, and that's why we use this SHA-1 revision number. So because SHA-1 revision numbers are not really good to remember, obviously, you have a few choices or a few different ways to specify a revision. So the first one is you can use just a few digits or just a few characters of this revision number, as long as it is unique in the repository. And Git will tell you if it's not unique. So most of the time, the first 4 or 5 characters are enough. You don't have to remember all 40 characters. And the second thing is you can use so-called ref spec or ref syntax, like this. This is, for example, this one is the revision number before the latest revision, because head points to the latest revision that is checked out, and this I don't know how you call it, one is just 1 back and 2, 3 back, etc. Master is just a branch name, etc. So it's really easy to have other ways to specify a revision. But I will go into the details later in the workshop. So these were the first 20 minutes, and I will come to the little bit more complex part, which is about branching and about, basically about branching. I will first introduce how branches work in Git, and then I will try to explain why Niels picked the branching model that he picked for phpBB. The first thing that I noticed because I used CDS before as a burden, and when I talked to people just knowing it's a burden, the first thing that they really were confused about was that there's no trunk directory and no branches directory and no text directory. If you come from Subversion, try to forget that, because the notion of branches in Subversion is totally different from the notion of branches in Git. It's it's really a completely new thing. So we will not have trunk tagged branches as directories anymore. In fact, a branch is not a directory anymore. We will just have the central checkout where we have a directory, a working directory, and if we check out a new branch, the files will be changed in this directory. So try to forget what you learned from Subversion to be able to understand what I will tell you now. I will take a look at ls repository, which is just a standard repository, Git repository. And I will always visualize a commit by this circle. And so when you do a new commit, in time after that commit, it will look like that. It's pretty easy. The thing you can notice is that there's a pointer to the parent revision or to the parent commit. And that's just because Git remembers the parent commit. I will come to this why it's that later. You will see it. So there's the third commit. I think the notion is pretty clear. Now, what happens? So Git just basically creates a new commit and remembers a pointer to the previous commit to the parent commit. Now, what happens if I go back one revision, like I check out this revision, and then I do a commit? In Subversion, this won't work, because Subversion will see there's a new commit, there's a newer commit, and you will not be able to commit to a repository that has a newer commit than the commit you checked out. You will just have to update and then commit. Well, in Git, this is still possible, and it will look like this, because it does exactly the same way it always did. It just creates a new commit on top of the current commit that you checked out, and it will remember a pointer to the previous revision. And if you do this a few times more often, you will get something like that. So it's just you check out a revision, you commit a new revision, and you can do this at any point or based on any revision in the repository. So you can go right ahead and check out phpBB, go to the first revision, check out the first revision, create a new commit, and it will do it. There is no problem with that. And because I don't know who of you have studied computer science, but if you have seen a thing like that, you might notice that this is called a directed acyclic graph. We do not have to really remember that, but most of the time when you read blog posts about Git or anything about that, you will see this notion. It's called DAG. So just to remember that. And this is the underlying data structure, how Git really orders and structures commit. And this is if you if you really want to understand how Git works, you have to understand this data structure. If you understand this data structure, it is the most easiest or the easiest revision control system in the world. If you do not understand it, it's probably the hardest revision control system in the world. That's the problem. Most of the people never learn that there's something like that in Git. And now, when we come to branches, if I see this, and maybe I'm a gardener, I work in a gardener's whatever, where I work with trees in general, I might notice that this looks a little bit like a branch, you know, like the literal word branch. Like this and this. Linus thought the same, and that's why he named this branch. So in Git, a branch is nothing else than a name for one of these branches. I mean, like, this is part because like there are two notions of branches, the one in the revision control system and the one in ordinary English. So if I see, for example, if I take a look at feature 1 as a branch, what is the feature 1 branch? And it's pretty easy because it's everything from the commit that is named feature 1, which is the purple one, I think, and every commit after that. So these are part of the branch feature 1. So if you check out feature 1, you will get a directory that reflects all changes created by this line of commits. If you check out master, you will get all changes that are created by, or the result that is created by these commits here, including those, because everything behind this master pointer or master sticker, I don't know how you call it, is a part of the branch. So this is completely different from all from branching models in all other revision control systems, in really all other revision control systems, including all of distributed revision control systems. In Git, a branch is just, I don't know, a name, sticker, whatever, for a commit and everything that's a parent of this commit. And what does it mean? If you delete one of those names, it's gone. Like the branch is not gone, but the branch name is gone. So you will be able to delete branch names, you will not be able to recover them in Git. The commit itself will not go away. So that's all about the gap. So if you understand that, that's easy.